Hello, welcome to this lecture. This is a continuation of the lecture that I already posted. Now the next concept is counting techniques. Why we are learning the counting technique is because in calculating the probability, we have to know the number of elements of an event, the number of elements of the sample space. So that's why we need the counting technique. There are 4 techniques. The first one is the addition rule, and the second multiplication, permutation, and combination. Let's discuss about the addition rule. In the addition rule, probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. But if A and B are mutually exclusive, it means A intersection B is implicit, implies probability of A intersection B is 0. So this is 0. If this is 0, then probability of A union B will be probability of A plus probability of B. What if A and B are independent? If they are independent, the probability of A intersection B is probability of A times probability of B. Then what we can do is we can substitute, instead of this expression, I can substitute this expression and then rewrite it. If A and B are independent, then probability of A union B will be probability of A plus probability of B minus probability of A times probability of B, because probability of A intersection B is the same with probability of A times probability of B. Okay, let's take this as a common, let's say. Will be probability of A plus probability of B as a common. And then what's left here, 1 minus here, probability of A. So then this expression will be probability of A plus probability of B. This is probability of A complement times probability of A complement. So either it will be like this, or we discuss about commutativity in the revision of the set theory. I can also write this as probability of B plus probability of A minus probability of A intersection B. Yeah, if I do it like that, then I will have probability of B plus probability of A times probability of B complement. So probability of A union B is either this one or this one. This expression is the same with this expression. So these are that I already showed you. Next is the multiplication rule. The multiplication rule is very important in real life. For example, if you are a designer, then you may use multiplication rule to design your website. Or if you are a registrar, you may also want to create ID cards for students. Then you use this technique. We are going to discuss examples. For example, the digits 0, 1, 2, 3, 4 are to be used in 4-digit identification card. How many different cards are possible 1 if repetition is allowed. In ID card, we know ID has to be unique, but we are just assuming here. Suppose repetition is allowed in ID card. And so how many different cards can you have? The digits are 0, 1, 2, 3, 4. How many are they? 5. And the ID, how many digits? 4 digits. In the first digit, 5 of them, you can put it. Like, for example, the ID with 0, 0, 0, 0, or 1, 1, 1, 1, or 1, 0, 1, 0, something like that. So 5 of them, you can put it here. Even again, 5 of them, you can put it here. Again, 5 of them, you can put it here. 5 of them, you can put it. So how many IDs can you have? 5 times 5 times 5 times 5, which is 625 different cards. But in real life, since IDs has to be unique, normally, how many different cards can you have if repetition is not allowed? Then you will have, in the first 5 of them, that is the next 4, and then 3, and then 2. So this is 5 times 4 times 3 times 2, which is 120 different IDs. Okay, let's continue. Another example about a design for a website is to consist of 4 colors, 3 fonts, and 3 positions. Then how many different ways? Because there are 4 colors, 3 fonts, and 3 positions. So 4 times 3 times 3 is 36. Okay, so this is all about this video. If you have any question regarding addition rule or multiplication rule, you are welcome. And please share and comment, and thank you very much. And yeah, that's it. See you in the next video.